Good morning, folks. It's Saturday morning, and I'm going to do a little video here to help clear up some misconceptions that I've seen creeping into our work this past week. We're talking about the structure of an atom, and what I'm going to do is I'm just going to start with the modern idea of how an atom is put together, all right? And all the things that are the most important things that are parts of it and the bits that you need to know about at this point, all right? As we go, I'll tell you who gave us each piece. Right, here we go. That is a modern picture of an atom. The blue and green dots surrounded by a long way away, the little teeny red flecks. Let's talk about what each of these dots and flecks are. Okay. The blue and green are packed into the center of the atom. The green dots, those are protons. When we're writing the shorthand version of that, we do a P with a superscript plus. It's the same place you would put the power number if you were doing powers of a number, right? So that's P plus, okay? The mass of a proton is so small that we don't talk about it in terms of kilograms or even grams. We use a different unit, a little teeny unit of mass called the atomic mass unit. And a proton has a mass of 1 atomic mass unit. And the charge? The proton, yes, it has an electrical charge, a positive electrical charge of +1. That's a proton. The blue dots that are packed into the nucleus with the protons, they are neutrons. And we use a little n to denote the neutron. It has an atomic mass unit an atomic mass of 1 atomic mass unit. It's got the same mass as a proton has, but it has a 0 electrical charge. It's neutral. That's why we call it a neutron. Okay? And then these little red flecks zooming around way outside the nucleus, those are electrons. And our shorthand way of writing those is an E with a superscript minus sign. Okay? The mass of an electron is 1 divided by 1,840 atomic mass units. So it's 1,840th of an atomic mass unit. It's a whole lot less massive than a proton or a neutron. Its charge is equal to -1. So here's what's going on with these subatomic particles. The protons and the neutrons are packed densely into the nucleus. Here what I've drawn is a carbon atom, and I'll explain why that's so in a couple of minutes. Then these little teeny electrons are whizzing around outside the nucleus, and the positive charge of the protons attracts the negative charge of the electrons to it. That's why these electrons stick to this atom. Okay, and what that means is you're going to have the same number in a plain atom. You're going to have the same number of electrons whizzing around outside the nucleus as you have protons. Okay, now we have a little more bit of math to talk about, or vocabulary to talk about. We have atomic number. We abbreviate that AT period, NO period. That is the number of protons. That's the number of protons in the atom, and that's how we define the element. So I told you earlier that this was a carbon atom. We know that because it's got 1, 2, 3, 4, 5, 6 protons. The atomic number of carbon is 6. An atom with 6 protons and, of course, 6 electrons to balance it out, to balance out the charges. An atom with 6 protons and 6 electrons is a carbon atom. The atomic number, the number of protons, defines the element. We have another vocabulary term here the mass number. That is equal to the number of protons plus the number of neutrons. And that defines something called the isotope of the element. So, I told you this is carbon, right? This is a picture of the most common version of carbon. 6 protons, 6 neutrons, 6 electrons. Its mass number is 6 plus 6, protons plus neutrons. It's the most common isotope, most common form of the element carbon. If I added an extra neutron to this, there would be 6 protons and 7 neutrons, and the atomic mass number, the mass number, would be 13, 6 plus 7. We would call that carbon 13. It's still carbon because it still has 6 protons. But it's got a more massive nucleus, right? Because it's got 13 atomic mass units in its nucleus instead of 12. So it's a different isotope, and it will behave differently than carbon-12. And then, of course, there's the famous carbon-14. 6 protons, 8 neutrons. And why is it famous? You've heard about that, right? That's the one that we use to date really ancient things. And when we get to talking about how different elements bond with each other, we'll talk a little bit about that. I want to say one more thing, though, about this modern model of the atom. Okay? What are these electrons doing out here? Well, they're whizzing around. Okay? And if you were able to take like stop motion pictures of the atom, you would find you would find a particular electron occupied, say, a certain kind of cloud, like maybe a cloud like this, maybe a spherical cloud like this, around the nucleus, 80% of the time. We call that particular cloud the orbital for that electron. And the shape of that orbital has to do with the amount of energy with which that electron is whizzing around. Another electron you might find occupied a sort of a barbell-shaped thing, like a teardrop, like a 3-dimensional teardrop here and a 3-dimensional teardrop here, and we call that the barbell shape because it's big at both ends. About 80% of the time. That's a different orbital, and it involves an electron with a different amount of energy. We will need to know about orbitals again when we talk about how different elements bond with each other. Okay? For now, this is what you want to know. This is the modern picture of an atom. Now, who gave us what? Well, the orbitals, those funny shapes, the sphere or maybe the barbell, we got that from some equations that were worked out, some math equations worked out by a man named Schrödinger. The neutron, a man named Chadwick came up with the idea that there had to be neutrons. He figured that out in the early 1930s. The electron and all this empty space and the proton, and really the idea of a nucleus, a positive nucleus surrounded by a whole bunch of empty space within which there were electrons, we got that idea from our friend Rutherford. Okay? Let's back up just a little bit and go to our friend Thomson. Thomson was the guy who gave us the idea of different elements. Okay? Different elements that combine together in particular proportions to give us the compounds that make up the materials we're familiar with. And the very idea that everything was made up of tiny particles, we got that from our friend Democritus way back in about 430 BC. Okay? So that's where all those pieces of our now modern theory come from. Have a good weekend, folks, and I'll see you on Monday.